Have you ever looked up at the night sky and wondered, what's out there? I mean, really out there. What happens if you could travel to the very edge of the universe, faster than light, and stick your hand out? What would you touch? Would your hand even go through? This isn't just a late-night thought, it's one of the biggest questions in all of science, and the answers are crazier than you can imagine. First, let's get our heads around the universe we know. We live in the observable universe. This is a giant sphere with us at the center, extending about 46.5 billion light-years in every direction. Why a sphere? Because light from distant objects has been traveling since the Big Bang, about 13.8 billion years ago. Since the speed of light is finite, we can only see the light that has had enough time to reach us. But here's the twist: the universe is expanding. The space itself is stretching. So those objects that were 13.8 billion light-years away when their light started its journey are now much, much farther away, hence, the 46.5 billion light-year radius. So, the first and simplest idea is that beyond our observable bubble, there's just more universe. Imagine being on a ship in the middle of the ocean. You can only see to the horizon, but you know there's more ocean beyond it. It's the same idea. The universe is likely vastly larger than what we can see, maybe even infinite. If you could teleport to the edge of our observable bubble, you wouldn't hit a wall. You'd just find yourself in a new region of space, with new galaxies, new stars, and a brand new observable bubble around you. From that new spot, our Milky Way might be completely invisible, beyond their cosmic horizon. It's a humbling thought: our entire cosmic view is just a tiny, local patch in an incomprehensibly vast expanse. But what if it's not just more of the same? Let's get weirder. This leads us to the multiverse theory. The multiverse isn't just one idea, it's a whole collection of them. One of the most popular versions comes from a theory called eternal inflation. Remember the Big Bang? The idea is that our universe started from an incredibly rapid expansion of space, called cosmic inflation. Eternal inflation suggests that this process never truly stopped. Our Big Bang was just one bubble of space that stopped inflating and settled down to form our universe. But outside our bubble, inflation is still happening, constantly creating new bubble universes. Imagine a giant, cosmic pot of boiling water. Our universe is just one bubble that has formed. All around it, more bubbles are popping into existence, each one a separate universe. These other universes could be wildly different from ours. They might have different physical laws, different fundamental constants, maybe even different dimensions. Some might be dead and empty, others might be teeming with forms of life we can't even conceive of. These bubble universes would be causally disconnected from us. We could never reach them, never see them, because the space between the bubbles is expanding faster than the speed of light. It's a cosmic family we can never meet. Another mind-bending idea is the brain world scenario, which comes from string theory. String theory proposes that the fundamental constituents of reality aren't particles, but tiny, vibrating strings of energy. For the math to work, it often requires more than the 3 spatial dimensions we experience. So where are these extra dimensions? The idea is that we, and our entire universe, are confined to a 3-dimensional membrane, or brain, that floats within a higher dimensional space called the bulk. Picture a single slice of a loaf of bread. Our entire universe is on the surface of that slice. But there are other slices, other brains, floating parallel to ours in the higher dimensional loaf. These could be other universes, potentially just millimeters away from us in that extra dimension, but completely inaccessible. Gravity, however, might be an exception. Some theories suggest gravity could leak between these brains. This could explain why gravity is so much weaker than the other fundamental forces. It's not weak, its influence is just diluted because it's spreading out into these other dimensions. It's even been speculated that dark matter, the mysterious substance that makes up most of the matter in our universe, might be regular matter on a nearby brain that we can only feel through its gravitational pull. So the next time you feel gravity, you might just be feeling the pull of a parallel universe right next door. Now, let's go even deeper down the rabbit hole. What if our universe is just a simulation? The simulation hypothesis proposes that our entire reality, from the smallest quark to the largest galaxy cluster, is an advanced computer program. We, our thoughts, our feelings, are all just lines of code. In this scenario, beyond the universe would mean outside the computer. It would be the base reality of the beings who created and are running the simulation. What would that reality be like? Is it similar to ours, or something utterly alien? And why would they simulate us? For research? For entertainment? We might be part of a cosmic video game or a historical reenactment for future civilizations. The scariest part of this theory is that it's incredibly difficult to disprove. How could we, as simulated beings, ever find evidence of the world outside our program? It's the ultimate cosmic prison. Let's circle back to a more classical idea, but with a twist. What if the universe is finite but has no edge? How is that possible? Think about the surface of a sphere, like the Earth. It's finite, you can measure its surface area. But it has no edge. If you walk in one direction, you never fall off, you just end up back where you started. The universe could be like that, but in 3 dimensions. It could be a 3-sphere. If you flew in a straight line in your spaceship, you wouldn't hit a wall. Instead, after an unimaginably long journey, you would return to your starting point, but from the opposite direction. In this model, there is no outside the universe because the universe curves back on itself. It contains everything that exists. The question what is beyond it would be meaningless, like asking what's north of the North Pole. So, which one is it? An infinite ocean of galaxies? An endless foam of bubble universes? A higher dimensional reality just out of reach? A digital simulation? Or a finite loop? The truth is, we don't know. And we may never know. These ideas are at the absolute frontier of theoretical physics and cosmology. They are born from mathematics and logic, pushing our understanding to its absolute limit. But the quest to find out is what drives science forward. Every time we build a more powerful telescope, like the James Webb Space Telescope, we are peering deeper into the cosmic darkness, further back in time, closer to the beginning. We're looking for tiny fluctuations in the cosmic microwave background, the afterglow of the Big Bang, that might be the bruise left by a collision with another bubble universe. We're searching for discrepancies in the law of gravity that could hint at extra dimensions. The answer to what lies beyond the universe is the ultimate mystery. It's a question that challenges our perception of reality itself. Whether it's more of the same, something completely different, or nothing at all, the pursuit of that answer tells us more about our own place in the cosmos. We are a curious species on a small planet, orbiting an average star, in one of countless galaxies, looking out into the vast, silent darkness and asking the biggest question of all, is this it? Thank you for watching. If you enjoyed this journey to the edge of reality, don't forget to like, subscribe, and hit that notification bell for more cosmic explorations.